Okay, hello everyone. Welcome to today's show. Today we are going to code a build system. I'm going to call the project bash.bs for build system, and it's not that as advanced as it sounds, because I'm gonna when I start any of my coding projects, I basically always start the same way, with creating a makefile and with basically the same contents, and then I create the different files, one C file, one H file, and so on and so forth. And it takes quite a while, so I was thinking we could make some templates and use them together with some bash code. So whenever we start a project, we simply use that tool instead and save us possibly 15-20 minutes of video time. Plus it's easier for you guys. Alright, so what do we need? I have prepared an empty folder on my server, and I'm going to create a file, and let's say this command will be bash build system bash bs, I think, .sh for now anyway, not when we have published the actual code on the after the installation process, but now it's okay. Alright, so we need some kind of templates folder, so let's create one. Let's just call it templates, and inside of here let's begin with a C file and an H file, or perhaps we should divide it by programming language. That makes sense. Or at least by template, and then the user can create own templates. Yeah, let's do that. So we will create an additional folder here, and let's call this template default C. So this is my default C template, and I will create a C file here, which, let's see what kind of name standard we should have. It should probably be something like project name.c, and then we will ask the user for the project name when we initialize the script. So we will have a project name.c, and we will also have a project name.h. Sorry. And the let's see, we can shut this down now. No, let's wait a little bit. Okay, so in the C file we will have the project name as a comment, and then we will include our own file, which is project name.h. And what else? Inside of the project name.h we can build the actual template. Let's start with adding this project name.h thing, and then a couple of includes that I usually use in most of my projects. So I will include stdio, I will include uni.std, and stdlib, string.h. I also want std bool so we can get booleans, and assert. And when I use assert, I always want to I always want to combine it with the error number, and then I need this one, include new source. What else? Is there anything else? Well, I want to include my own library, birch utils.h, because I basically use that in every on every project nowadays. So let's include that one. Okay, it resized the window when I zoomed out. That's a little bit annoying. Just 1 second so I can fix this. It should go somewhere like the same as that one, I think. All right. So that was birch utils. Then I always do something like a function declaration signature for the main function, and it takes an arg, it takes an int and a char double star. I also want to have my type definitions, so I will do type def. Let's see, let's start with unsigned char, which is an int 8. Then we go for unsigned int, no, unsigned short int, which is int 16. We'll also do unsigned int, which is int 32, and also unsigned long int, which is int 64. And I will also create those macros for the typecasting. So I'll create one 8 for int 8 star. Let's have a 6 for int 16. And if you wonder how I select those names, well, this is int 8 and this is 8, quite a self-explanatory. But I want everyone to be one character, so I take the last number and put it here. So int 16 becomes becomes $6. Then we'll have 2 for int 32. We'll have a 4 for int 64. We'll also create a C for char, and I will create a I for int. Okay, this is enough, I think. This is a good starting point. Let's see that it uploaded correctly. Looks right. And we don't need to add anything else here. I think perhaps we can do the main function though. something like that. Alright, so we have our C file and our H file. The next logical step is to create our makefile. So let's do that. And what do we need in here? Let's make this makefile really good so we can use it in all different kinds of projects. So first of all, we might have some flags, and we might have some LD flags for the linking. And then we'll have some kind of compilation step of our C file. And in that case, we want to create project name.o, and the dependency is project name.c and project name.h. And what do we want to do with this one? We want to run cc with the flags, and then we want to take the first source file and run it against -c. That should be it. And in this case, we want to create a binary called project name, and the dependency is project name.o. And to link this one, we will run cc with our flags, and we take the source file, or the source, and we run it to the destination, and we include our LD flags, like so. We do also want some kind of clean step, and in this case we will simply we remove the O files and the project name binary, and that's it. And we want to run the all will include first running clean and then running project name. And we will mark the all and the clean as phony, since they are not producing anything on their own. The flags I usually use is O2, W wall, and let's set the standard to C to X. And LD flags, we need to include the lib virtuals. Or maybe we could call it just LBU virtuals. Okay, we have a makefile. So these are the three things that I almost always use when I start a project. So the only thing really we need to do is create a simple bash script where we can choose a project name, and we can choose a template, and this bash script in turn will it will replace the project name in all those template files with the actual project name, and then it will install those into the project folder. Okay, well, let's begin. So this is a bash script, so we put in the hashbag, and what are we going to give as arguments? We can give the project name as an argument. So let's say pname equals $1. Yes. We also need some kind of constant where this script will grab its templates from. So let's say we use tdir, we set var bash.bs /templates. That's good enough. Yeah. Okay, so that's probably all that we need. Let's do a quick sanity check. We will check if the p name is 0. If so, we're gonna print the usage and exit 1. We will also check that our tdir exists. I think that's -d. We need to double check that. Tdir. And if this exists, what do we do? We should check if it doesn't exist, right? So where do we put the exclamation mark? I think here. Okay, if that doesn't exist, we need to print an error. So let's do to the standard error, we echo unable to find template directory. And then we show which one it is. And we exit 2. And the third thing we can check is if the project directory exists. So in this case we do this, we check if pname, let's be a little bit more specific. So let's do p directory is equal to /pname. So directory already exists, and we will echo project here already exists. And we exit 3, 5. These are the different checks we needed to do. Okay, so let's save the current working directory. And let's go into the template directory, td. Now we want the user to select one of the templates. And why not use the very nifty command select, which is built into bash. So we just do select x in, and then what we want to check for. So if we just do this, it will list all the directories in our current directory. And do. So what should we do when the user has selected something from this list? Let's set template equal to x. Break. Okay, let's see how it's working this far. Let's change the permissions of a file so we can run it. Usage command not found. That's right, we never created the usage function. So let's do that. So we have usage, and all we're going to do is we're going to print to the standard error. We're going to print usage $0 and project. So, and then we're going to exit 4, I think. Yeah. Or not exit, by the way. Let's just return from this function. That way we can decide for ourselves when we want to quit or not. Okay, so if we give this a project name, like ABC, it says it's unable to find the template directory. We need to create, we have a template directory, right? So we just need to temporarily point it to a different location. So let's go into here and let's do this, and let's comment out this one, and instead we do this and templates. So if we run the same command again, need to give it permission. Okay, please select the template one default.c. So I select that. Okay, cool. So now we have selected a template and we have defined all the constants and sanity checks. What's left to do is make a copy of that template, of the selected templates directory. And yeah, let's start with that. So first of all, we need to go back to the directory where we were. So let's just do cd $cur. Then we will define, no, let's just do this. We use the cp command to copy with the -big R flag, which copies the subdirectories and stuff. And what we want to copy is, let's see, we want to go to the template directory. Let's do this. And inside of the template directory, we want to use the actual template. And where do we want to copy this? We want to copy this to the project directory. Did we have one of those? Yeah, pdir. So we copy it to pdir. Okay. So yeah, when we have done that, what are we going to do? We should go through all the files and one by one replace the project name. That's right. So we need some kind of loop then. So for x in no, let's seed into it. Make things a little bit simpler. So cd pd and for x in everything do. So we need to check if the file name contains project name, and if so, we need to change the file name as well. So let's do something like this. The x variable currently contains the name of the file that we are for eaching, so to speak. So let's create a variable where let's call it new, and we want to run something like set, and then we want to substitute project name with the project name. I think we call it project, right? No, p-name. p-name. And let's do G as well. And we want to feed the file name we are currently examining, like so. So now it should have the correct name inside of new. And now we want to run sed again, but this time we're going to use it to create our new file. So we will use the same kind of substitution logic. So we'll change project name to p-name every position globally. And let's see, we want to supply the old file name, and we want to create the new file name. And if this succeeded, so if the new file name exists, then we delete the old. And that's basically it, I think. Yeah, I think this is it. Let's see if it works. So let's say we want to create, let's clear the screen. Let's say we want to create a project which is called, let's take one of my old projects, for example. So, what kind of things did I do? Let's say the Toralize. And we press enter. We select the default C template. And we did not get an error. That is important. And we have a Toralize directory. If we go inside of this, we will have a Toralize.c and a Toralize.h. What about the makefile? So let's see. If we look inside the templates folder, we do have a makefile. What happened to the makefile? It just disappeared. Why is that? So the new file name is project name to this, but it shouldn't affect the makefile name. And if we run this against makefile, from makefile to makefile, that's right. That doesn't really work. So we need to check if the old file name is equal to the new file name. And then we will do nothing, right? No, we will still do the substitution. But but we need some kind of middle step with a temporary file. So let's just do to the temp, and then we move the temp to the X. Otherwise, we will do this. Okay, now I think everything should work. So let's remove this Toralize. Let's give it execution permission. And let's run it and create Toralize again, or Toralize 2 perhaps. We select the default template, go into the Toralize, and it still doesn't work. And the weirdest thing is we don't even get an error or something. Because it should copy the entire file contents, right? Default C. There is a makefile in there with the correct permissions. Why doesn't this work? Let's do some debugging now. If we just echo out X, because I want to know if it really parses through every file. Let's do this. And then we'll just do bs.sh and Toralize 3. Let's check what happens if we run it against 2, by the way. Yeah, that works. So let's run it against 3. And we select the default template. Yes, it finds a makefile. So let's do something like this. This is a new thing I have discovered, that when I add temporary things to my code, like debugging info, I put it all the way to the left, because then it's very easy to distinguish and remove when we are done. So let's say step 1, and then we will do an bin ls, so we know the lay of the land, so to speak. So let's remove this and put it back, and then if let's do a step 1.5 here, and then after both of these we will have step 2. Aha, now I see. Okie dokie. Did you also? It's this. We remove the old file, but the old file has the same name as the new file in the case of makefile. So that's not a good thing to do. We do only want to delete this if the old is not equal to new. So let's remove this file and put it here instead. And we will space this out to here. And now I am pretty certain that everything will work as expected. So let's remove the Torlights 2 and 3. Let's give it permissions. And we run it against Torlights. Select the first template. Okay, we didn't remove all the stuff, it seems. Yeah, let's remove this echo. But we don't need to rerun it for that. So let's go into the Torlights. And let's see what we got. So if we cat the makefile and echo, let's see, flags O2 wall, flags LBU, phony, all clean, Torlights. That's great. And we have Torlights here, the binary, and Torlights O, Torlights C, and Torlights H. And it will remove the Torlights. If we do clean, let's check out the .c file. And echo. Well, it's not much here, it's basically just this and this. So that works. I want a .c at the end here though. So let's alter this so I don't forget. Right here. And yeah, we did it correctly in here. And finally, let's see if the H file works as expected, which I believe it should do. And we have everything, it seems. And the Torlights.h. So, yeah, I'm pretty satisfied with this. It's a very easy project. It's not a lot of advanced stuff. We could, however, add more advanced stuff in the future because there's a lot you can do with a build system. But I just want something simple which speeds up my initial file creation, basically. So before I end this episode, what I want to do is I want to put the path back. So let's remove this and let's have this instead. And I want to install this globally so everyone can use it on Core Planet. So how do I do that? I'll go in as root and I will move the templates directory to, no, let's create var, I don't remember which one it is, bash.bs. So let's create that, var yes. And we also want to move the script itself, so let's move bash bs to user bin bash bs, and I will not have the extension. So now every user on CodePlanet can just run bash bs and create their project. If you like this video and you want more videos of this kind, please like and subscribe, and the code will be available for 48 hours as usual on our code repo. And if you want to access older stuff, you need to be a paying member. Alright, thanks for watching and thanks for today.